Okay, we're going to describe the key features of these two graphs, and it'll help you finish up that assignment. So I want to remind you that most of everything on here is looking at x values. Okay, the range is a y value. The max or min is a y value. The y-intercept is a y value. But everything else is an x value. Okay? So what is the domain of that blue graph? All real numbers. And again, we're looking at the x-axis. So is there a point corresponding to that x value? Yeah, where is it? It's up here somewhere. Is there an x is there a part of the graph corresponding to that x value? Yeah, it's down here. This one hits there, this one hits there, this one hits up there, and every single x is represented somewhere on the graph. And in fact, as long as your graph is a quadratic, then your domain will always be all real numbers. The only time you'll have a graph that is not all real numbers is if you have like divide by x, and then if you plug a 0 in, you can't divide by 0. The other problem is if you have a square root graph and you have a negative number on the inside, then your domain will be restricted. But all other polynomials are going to be all real numbers. Okay, so we use the double R for that. What about the range? Are all of the y values represented? No. Which y values are not represented? So we have a minimum right here at -1, -4. The graph does not go any lower than that. So is there a part of the graph corresponding to y equals -5? No. If I draw that horizontal line, it misses the graph. And in fact, anything from here down is not represented. So to write the range, we have to think about the lowest possible value. What is the lowest possible y value? -4. So -4. What is the highest possible y value? Infinity. Is -4 included? Does the graph actually hit -4? Yes, so we use a bracket. Does the graph actually hit infinity? No, we can never hit infinity, so that's a parenthesis. And again, you might want to put equals y. X equals on most of them, but y equals on the ones that are not x's. Okay, increasing. Where is this graph going up? So from here over, the graph is going up. And remember, we always read from left to right. So if you imagine driving on this curve from the left side to the right side, when is your car facing up? And it would be after -1 to infinity. So it's increasing from x equals 1 to infinity. Is the car facing up at 1? At -1, thank you. Is it facing up at -1? No. Is it facing down? No, it's perfectly level. So that point at -1 is neither increasing nor decreasing. So -1 gets a parenthesis, and infinity always gets a parenthesis. All right, where is the graph decreasing? So it's going to be from -1 down, which is this portion of the graph. What is the smallest number in that set? -infinity. What is the biggest number in that set? -1. Do we include either of those? No. Both of those are a no. Okay? Where is the graph positive? Well, if we look at the graph, this portion is positive, and then this portion is positive. So we have two pieces. So we're going to have the union of two intervals. What is the smallest number on the left side? So if I look at this portion here, what is the smallest x value in that portion? Negative infinity. What is the biggest number in that portion? Negative 3. So infinity always gets a parenthesis. Is the graph above the x-axis at negative 3? No. So it's going to be a parenthesis, and I'm going to union that with the second side. Oh, that's interesting. What is the smallest number on that right side portion? 1. What is the biggest number in that portion? Infinity. Do we include negative 1? Or sorry, 1. Is the graph above the x-axis at 1? No, it's on the x-axis. Parenthesis and parenthesis. All right? Where is the graph negative? It'll be this portion here. So what's the smallest x value in that portion? Negative 3. What's the biggest x value? 1. So negative 3 comma 1. Do we include either of those? No, they're both on the line. Okay. Does this have a minimum or a maximum? Minimum. What is the minimum value? That's the point. The minimum point occurs at negative 1, negative 4. But what is the minimum value? The smallest y value is negative 4. All right, what are the zeros? Negative 3 and negative or positive 1. What is the y-intercept? Now that I've made a mess of the graph. Negative 3. Y equals negative 3. Okay. Now end behavior. As x goes to negative infinity, which is on the left, what direction does the graph travel? Up or down? So if we look over here, as the graph travels to the left, does the graph go up or does it go down? Up. So f of x approaches infinity. As x approaches infinity, which is to the right, f of x approaches infinity. On a quadratic, is it possible to have one go to infinity and one go to negative infinity? No, they're either both positive infinity or both negative infinity. Okay. Hang on a second. Oops. Okay. Oops. That also. Okay. Let's look at the second one. That didn't work. Okay. So for number 2, what is the domain? Auto numbers. What's the range? Everything from 0 to negative infinity. So we always list the small one first. What's the smallest number in that set? So y is from negative infinity to 0. Do we include the 0? Yeah. Does the graph actually hit y equals 0? Yes. So we put a bracket. Where is the graph going up? from negative infinity until x equals -2. Where's the graph going down? From 2 to infinity. No, this is an x value, right? Which x values make the graph go down? Everything from 2 to infinity. Oh, here I am trying to be smart. I thought you said negative infinity. There we go. Okay, where is the graph positive? It's never positive. So you can write never or nowhere or it isn't. Or you can use this symbol, which means the empty set, the empty interval. So the answer is the set of numbers that has nothing in it. So whenever you see that symbol, which is a circle, a 0 with a line struck through it, that just means there are no answers that fit that requirement. Where is the graph negative? So one way to list it is negative infinity to 0, and then from 0 to infinity. How would you describe that if I asked which numbers are part of the negative portion? Everything but 0, right? So, sorry. Oh, I wasn't paying attention. It's actually -2. So everything but -2. So we can actually write that mathematically. We can say all real numbers, but x is not allowed to be -2. So that just means every possible answer but -2. So whenever you have just a number or a couple numbers that don't belong, we usually just write all real numbers, but x is not allowed to be whatever point you want to throw out. Okay? Does this have a max or a min? Maximum? Where does the maximum occur? The highest number is 0. What are the roots? Where does it cross the x-axis? At -2? Wait a minute, I thought every quadratic had to have 2 roots. Well, technically, this does have 2 roots. It's -2 and -2. Because if I were to draw a quadratic up here like this, that has 2 roots, 2 roots, 2 roots, and now it has 1. So those 2 roots have become 1. So technically, it only has 1 0. But you'll find out in the next chapter that you can create that equation, that quadratic equation, if you treat it as though it has 2 roots that are the same. All right, y-intercept. Y equals -2 because it crosses y-axis at -2. And behavior. As x approaches negative infinity, f of x approaches negative infinity. As x approaches infinity, f of x approaches negative infinity. So both endpoints are going down. All right. I'm going to give you a little bit of time to finish your describing worksheet, and then we'll probably start the next one. Okay?